The relationships of the three sides of right angle triangles is a pretty impressive relationship. It's a fairly simple one, and it's been around for thousands of years. So we can go back to Mesopotamia, and then around 1800 BC, somewhere around there, we have clay tablets that have the Mesopotamian version of Pythagorean theorem on it. We have back in ancient Egypt where they're building their pyramids, and they used ropes with 12 knots tied evenly spaced, which resulted in a 3, 4, 5 triangle. So there's our 90-degree triangle. We have the Indian version, which was compiled somewhere in the 8th to 6th century BC. So that's approximately 3 centuries before Pythagoras. Pythagoras is the name that we frequently use to refer to this relationship between the three sides, and he was a Greek, and he's somewhere in and around 570 and 495 BC. And it maybe wasn't even him. There's, oh my goodness, the story behind this is quite huge. Feel free to research it. There's lots of great stuff out there. The relationship itself is what we really want to know. So the relationship says that when I have a 90-degree right angle triangle, one short side and the other short side are related to the long side, such that the square of the longest side is equal to the sum of the squares of the shorter sides. So the longest side has a name called the hypotenuse, and the two shorter sides are often called the legs. So let's use that. So here I have a right angle triangle, and I want to figure out the area of this square, and then I'm going to use the areas to determine the side length itself. So when we have a right angle triangle, we can take a side length, and then to square it, that means I'm drawing a square beside it. So 25 meters squared, well, 25 is 5 times 5, right? 144 meters squared, so a rectangle that's 144 meters squared. So there's the square. And well, what's the square root of 144? 12. So that means each one of these side lengths is 12. So that means this side length is 12. This side length was 5. And we want to figure out the last one. Well, if we use our relationship such that the longest side squared is equal to a short side squared plus the other short side squared. So that means I've got a 5 squared plus a 12 squared. And didn't we just say that that 5 squared is the 25? That's where the number came from. And I've got this 12 squared, which is 144. Add those up and we get 169. So that's the length of the square. That's this whole area here. So there's our first part. There's finding the area. So my area is 169 meters squared. And then to get my side lengths, to get rid of a square, we need to square root it. Which means we're looking for the number that multiplies by itself to equal 169. And the square root, the number that multiplies by itself to get 169, well, that is 13. Because 13 times 13 is 169. So that means that this side length right here is 13. So C equals 13 meters. What about if we need to find the small side? Okay, well, I can see that here's my 90 degrees, which means, so if this is my 90, that means that the longest side, the 90 looks at it, that's my hypotenuse. So that's my C. And then it doesn't matter who you label A and B, it just matters that A and B are the two short sides. And these are the two sides that go around the 90. So then we always start with an equation, C squared equals A squared plus B squared. So the longest side here is 10 squared. One short side, well, we don't know it, so we'll leave it as the letter. And then the other short side, which is 8. So let's follow our order of operations here. Let's square our numbers. So we've got 10 squared is 100 equals A squared plus 8 squared is 64. To get the 64 to the other side, we're going to do the opposite. So we're going to subtract 64 from both sides. 100 minus 64 is 36. And then to get rid of the square, we need to square root it. So that means that the short side I'm looking for is going to be equal to the square root of 36, which is 6. And then we look at our question and I see my units are all in feet. So my shortest side is going to be 6 feet. So that's basically what we do. We're going to start with our equations. We're going to stick in whatever numbers we know. And if we're looking for the longest side, we add them up and square root it. And if I'm looking for one of the shorter sides, I have to subtract the short side from the long side. Make sure you square each number individually, and then square root to finish it off. Let's try a few more. So here, for each of the following, use the given areas to determine side lengths A, B, and C. So let's put some numbers on there. All right, so on my diagram, I've inserted some areas. So that's the area of the square for each side. And I want to use each area to determine the side lengths, A, B, and C. So as we were saying, the side length of the square is equal to the square root of the area. So A will be equal to the square root of 144. And the square root of 144 is 12, so it'll be 12 inches. B is going to be the square root of its area, right? That's how we came up with the area in the first place, is because both side lengths are going to be B. So B is going to be the square root of 400. So that'll give us 20 inches. And then to finish us off, our hypotenuse here, our longest side, is going to be the square root of 544. That one doesn't work out perfectly, but it is approximately 23.3 inches. Okay. And then determine the length of the hypotenuse for each triangle. So here, I just have my side lengths labeled. So we need to give it our letters. So my longest side is my hypotenuse. So that's my C. And then you can make whichever one you want, A and B, doesn't matter. Write out our equation. So C squared is A squared plus B squared. Pop in your numbers. So I don't know anything for C. We're looking for that. A we decided was 15, so we're going to square that. And B is going to be 10. 15 squared is equal to 225. 10 squared is equal to 100. Add those up, 325. So that's what C squared is. We got a square root in order to finish our answer, finish our question. So the square root of 325 is going to be equal to 18. What are our units? Meters? Meters. So that's how long the hypotenuse is. Determine the length of leg L in the triangle. So I've picked just different ones off of your worksheet. I didn't pick all of them, and I kind of switched it up a little bit. So this is A to A. So we've solved that one. We did one of the ones from question 3, only I just picked different numbers. Question number 5 was looking for the hypotenuse. Question number 6, and let's look at D. We're going to figure out the length of the leg. So just like before, the longest side, which is across from the 90, that's our 90. That's going to be our C value. One of our legs is our A value, and one of our legs is our B value. We write out our equation, C squared equals A squared plus B squared. Pop in our numbers, so in this case we know a number for C, so that's 6.6 squared equals, we'll use the little L for our A, plus B is our 6.1. So that 6.1 is squared, and that 6.6 is squared. So 6.6 squared is equal to 43.56. We're looking for that L squared, and 6.1 squared is 37.21. In order to get this guy all by itself, We got to move the 37 to the other side, so we're going to subtract it from both sides. And then 43.56 minus 37.21 is going to give us an L squared of 6.35. Square root our square. And our final answer is that our length is equal to 2.5. I will leave it at 2.5 inches. Good. So hopefully this will help you finish up the rest of your handout. And good luck. Let me know if you have questions.